This is Jacob Abraham, and my partner is Brandon Davis. Our project is CFGs for the English grammar. The basis of our presentation is answering this question, and that is, how accurately can the English grammar be parsed as a context-free grammar? Basically, is there a CFG that can accurately parse all possible types of English sentences? The common belief is maybe, but so far there's no perfect CFG. However, a CFG can be made for most general English sentences. We are going to show the CFG and explain the three types of sentences it parses. We will also talk about adding more complexities to the CFG. So this is a generalized CFG that we found. What's important to note is that the first variable s depends on the type of sentence structure, but the rest of the CFG stays the same. This CFG is broken down into the basics such as nouns, verbs, and pronouns. This is a continuation of the previous CFG. As you can see, these are terminals that have specific examples. So this version of CFG covers everything from nouns, verbs, all the way to prepositions and conjunctions. Previously, I mentioned how the first variable s depends on the type of sentence structure. There are three main ones we're going to discuss. They are declarative, imperative, and interrogative. Declarative sentence structure is just a general statement that conveys some kind of information. For example, I drove the car home. This structure causes S to have NP-VP. This means the sentence will start with a noun or a pronoun and contain an action. This is just a parser for the example above. As you can see, the NP goes down to I and the VP breaks down all the way to drove the car home. The second type of sentence structure is called imperative. This is basically a commanding statement. For example, bring the keys. When it is an imperative statement, S will just have VP because the sentence will generally start with a verb. Again, this is an example of the CFG parsing the example above. The last sentence structure is called interrogative. This is basically a question. In this case, interrogative sentences will either be aux NP VP or WH NP VP. Aux is any sentence that starts with the words such as do, does, can, and WH are used for sentences that start with who, what, when, where, and why. For example, which flight serves food? Again, the CFG is parsing the example. So this is an updated version of the previous CFG. As you can see, S has been given the different possibilities of the three sentence structures.
Now what we have just shown you is a very basic context-free grammar, that while it gives you a good example on parsing simple English sentences, it is still largely deficient in parsing the language as a whole. There are various different rules of English that when applying them can quickly make one CFG large and complex. The ones listed here, quantifiers, adjectives, conjunctions, and gerunds, we will be showing a short example of. Quantifiers are words like one, two, and many that indicate the amount or the quantity of a noun. With our CFG, the quantifier, labeled Q here, will occur in a noun phrase NP in between the determinal and the nominal variables. Like the determinal, when parsing, quantifiers can be optional, with its terminal being an empty string. To include adjectives in the CFG, another variable would be made, in this case AP, which stands for adjective phrase. AP can result in either just an adjective or an adverb followed by an adjective. The AP would lie after the determinal and quantifier, but before the nominal. And like the other two, AP is also optional when parsing. Conjunctions, which are words like and or, complicate things further, as it allows the combination of independent and dependent clauses. In terms of our CFG, this would be the combination of the sentences, which are S, and the noun phrases and verb phrases, which are NP and VP. And our final example, gerunds. Gerunds are the endings to verbs like ing and ed. These can be tacked on to the end of the verb terminals. After adding these few English grammar concepts to our CFG, we get this. As you could probably see, this current version of our CFG is a good deal more complex than our previous, and this is only after trying to implement a fraction of the intricate rules of the English language. So obviously, what we have just showed you is by no means a complete CFG for English grammar. As stated before, there is no realistic way to create a CFG that works for all possible English sentences. But, with enough effort, you can create one that handles most, or in our case, a subset of the sentences. Thank you.